Let's continue our introduction to the nomenclature of alkanes. So far we've seen how to identify the root. We first have to identify the longest continuous carbon chain. We've learned how to name alkyl substituents. We've learned how to number the chain so that the chain is numbered so that the first substituent has the lowest possible number. And we've learned how to put it all together. The substituents are listed in alphabetical order. Hyphens are placed between numbers and letters, and commas are placed between numbers. We've also learned that the alkanes do not have any spaces in the names. So what do you do if there is more than one longest continuous chain? For example, in the molecule shown here, I could identify two chains that are 7 carbons long. What we want to do is to choose the chain that has more substituents to determine the root. As drawn on the left-hand side, with the red continuous chain, I would have 3 substituents, 2 methyls and 1 isopropyl. As drawn on the right-hand side, I have 4 substituents, 3 methyls and an ethyl. We want to go with 4 substituents. So here's our longest continuous carbon chain. When I number it so that the lowest possible number is assigned to the first substituent, I number it this way. And when I look at portions of the molecule, the root is 7 carbons, so I know a heptane is going to be a portion of the name. I know that I've got a 2-methyl. I know that I've got a 4-methyl. I know that a part of the name is going to be 5-methyl. I also know that a portion of the name is going to be 3-ethyl. So now when I put that all together in alphabetical order, I have 3-ethyl, alphabetized by the E, 2, 4, 5, trimethyl, and that's alphabetized by the M, heptane. Sometimes we'll see rather complex substituents, and it may be necessary to use parentheses to name those substituents. To use this method, let's first look at some complicated substituents and learn how to number them. You'd find the longest continuous carbon chain, and so if I've attached to the rest of the molecule here, my longest continuous carbon chain starting from the molecule is here. It's a 3-carbon chain, so it's a propyl group. And off of the propyl, there is a methyl attached to carbon 2, so this will be a 2-methyl propyl group. Moving over to the right, if the rest of my molecule is here in the bottom corner, then I am going to have the longest continuous carbon chain is 1, 2, 3, 4 carbons long, and I have methyl groups on carbons 1 and 3. So this would be a 1,1,3 trimethyl butyl group. And the example on the bottom, the rest of the molecule is here. Now I've got to figure out which way to number this chain. I have 2 options. I can number to the right and have an isopropyl group as the substituent, or I could number to the left and then I would have an ethyl group and a methyl group. This goes back to the rule that we take the longest chain with the most substituents. So in this example, I would number it so that I have a 1-ethyl and a 2-methyl. So let's see it in action. Hopefully you can identify the 2-methyl propyl group off of the larger alkyl chain. The chain is a nonane, 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons in the chain, so we know that the root would be nonane. You could name this as an isobutyl group, that's absolutely acceptable. But if you wanted to name it as a 2-methyl propyl group, you would do so as indicated here. First we identify which carbon it's attached to. It's attached to carbon 5, so it's going to be a 5, 2-methyl propyl, nonane. And as a second example, the 1-ethyl 2-methyl propyl group is attached here. For this molecule, I would number right to left. It is also a nonane, 9 carbons in the longest continuous chain. I have an ethyl group on carbon 3, and on carbon 5, I have the 1-ethyl 2-methyl-propyl substituent. So let's summarize what we've talked about with the alkane nomenclature. It's first important to identify the longest continuous carbon chain. This will not necessarily be left to right on the page. It might start bottom left and go to top right. It might circle around. You just have to look for it. We want to number the chain so that the first substituent has the lowest possible number. We're going to name those substituents and identify the location of them by the number on the main chain. So I might have a 3-methyl or a 2-ethyl. The substituents are listed in alphabetical order. We're going to include iso, and when we see it, we'll include cyclo. We haven't had an example of that yet. We're going to ignore di, tri, tetra. We're going to ignore hyphenated prefixes like in, sec, or tert. And it's important to remember where to have commas, hyphens, and so far, no spaces. Hyphens go between numbers and letters, commas go between numbers, and we've just seen how to use the parentheses for the more complicated alkyl substituents. And I'd like to acknowledge my references. I used Wade's Organic Chemistry textbook, and I used McMurray's Organic Chemistry Power Lecture CD for many of the images in this slide.